This is Algebra 1, Lesson 2.1, Real Number Line, beginning on page 63 in the text. We have two goals that we're shooting for. We're graphing and comparing real numbers using the number line, and we're finding opposites and absolute values of numbers. Got a whole slew of definitions to start. The first one is, what are real numbers? Everything we deal with in this class will be considered real numbers. Everything that you've typically worked with throughout your entire math career and mostly in your entire life would be considered a real number. Here's an example of something that is not a real number, because most people don't understand this concept until they see this. This means the square root of something. Most of y'all or some of y'all are familiar with that. The square root means what times itself is that number. So the simplest one for most people is 1, but we'll look at this one real quick. The square root of 4 means what times itself is 4. Most people in here understand that 2 times itself is 4. Okay. That's all of those are real numbers, everything I just showed you. What is not a real number is this right here. The square root of -4. Okay. You can, however, use this, and they devised a way to where we can work problems like this, because if you get the number 2, 2 times itself is 4, and -2 times itself is 4. Neither one of those numbers times itself gives you -4. So what they did is to create this to where you can actually work it, they created what's called an imaginary number. And this is where there are other numbers that are considered not real, but this will be the first type you'll be exposed to in your junior year. Imaginary numbers means if you multiply I times this, imaginary, I is for imaginary, times the square root of 4, now you can simplify this out. What it does is it takes that negative out of the problem, and it makes it to where you can say I times 2, because 2 times 2 is going to be 4, so 2I. But anyways, everything in this class, don't let what I'm saying, all of this part right here, confuse you. We will not see this in this class again. I just want to show you, because most people don't understand, well, what's a real number? Well, that's everything you deal with. Okay, well, why do we call it real numbers? Because we have to make that distinction, because one day you're going to run into something that's not a real number, and that'll be the first one you'll run into right there. Okay. A real number line looks like this. Everybody, horizontal line, and it pictures real numbers as points. What that means is if 0 is right here, this is a representation of the number 0. This is a representation of the number 133 right here, that point. Because there's an infinite amount of space in there. It doesn't talk about how small or how big it is. 133, it's a representation. Negative numbers are on the left side, numbers that are smaller than 0. Everybody in here understands that concept. If 0 is the balance point, positive numbers are all over here on the right-hand side, and all of your negative numbers infinitely go to the left-hand side, something that's less than 0. Again, same thing I just said, positive numbers are all of the numbers on the right. So if 0 is there, your positive numbers are everything on the right, greater than 0. Integers, or what we think of, and I'm going to write this with quotations, because this is not technically correct to write it like this, but we think of these as whole numbers. Integers, anytime you see that word, and you're going to see that word some more, so get used to it, whole numbers. The numbers you count by, even -3, -2, 1, 743, that's an integer. What is not an integer is 1.2. That's not an integer. What is not an integer is 3/7. That's not an integer. Not what we would consider whole numbers. But it's not technically whole numbers, because there is a different definition for a whole number. Okay? Okay, this is the part, this is a confusing definition. Somebody was asking me about this definition earlier. What is a graph? Well, graphs are many different things. Most people, when I say draw me a graph, would draw this without hesitating. This is really considered a Cartesian plane. It shows all your numbers that are positive going this way, positive going this way, negative going this way, and negative going this way. But all a graph is, if you want to talk about things being technically correct, all a graph is the number itself. It's the point. If this is a number line, and this is 133 from earlier, all the graph is the picture that's represented that represents that number 133. That's all a graph is the picture that represents 133. We will graph equations eventually in this class. All the graph is going to be is the picture that represents the line itself, not the plane it's on, not the number line it's on. This is the graph right there. Plotting is drawing the point. Drawing the point is called graphing the number or plotting the point. So in order for me to plot 133, it's not represented yet. Now I plotted it. Now it's there. Drawing it or putting it there is now plotted. Opposites are easy for everybody. Opposites are whatever the value is, it's the one on the that's the same distance from 0. So again, I keep using 133. I'm not sure why I came up with that number a minute ago, but I'm just sticking with it. The opposite of 133. This one is 133 spots away from 0. And I know there's way more humps you can make than that to get to 0. The opposite of it is the same 133 of them this way. So it'll be negative 133. Opposite concepts are really easy for most people. If it's negative, it becomes positive. Positive, it becomes negative. The absolute value, there is no negative value for absolute values. Absolute value, the easiest way to think about this one is it is a distance. It is a distance. If this little kid right here is trying to measure from himself to this other little kid over here, and he takes a tape measure and he measures out and he says, okay, it's 10 feet. Going from him to him, it's 10 feet. If he takes the same tape measure and he lets it wind up and then he throws it over to this kid over here and he measures it out, and now this time it goes this direction, is it going to be a different value than 10 feet? Will it be considered negative 10 feet? The tape measure is going to say 10 feet, right? That's what absolute value is. The distance from one thing to the next. It's not positive or negative because it's all positive. Distances are all considered positive. There is no negative value. All velocity is speed, and it is used interchangeably with speed a lot. But it's speed with one extra thing. It has a direction going with it. Okay, up is positive, down is negative. So if the speed of something is going up this much, so from here to here, you would tell what its speed was, and we'll look at what that means more when we go through things like that. But not only will you tell its speed, you'll tell that it's going positive. It's going up from, say, 6 miles an hour to 15 miles an hour. So just think of speed with a direction. It's velocity. A counterexample is something that proves it's false. The sky is always blue. Okay, I just made a statement. Could be true, it could be not true. Okay, well, what about when it's nighttime? The sky's black. Well, that's a counterexample. The sky's black. The statement I just made, the sky is always blue, is false. I just proved it false. Once you prove something false one time, you don't have to prove it false again. The counterexample would be, what about nighttime? It's black. In that sense. Okay, let's look at example number 1, comparing real numbers. Graph -3 and -7 on a number line. Okay, it's real easy. Some of these are done for you. But at -7 and at -3, those are the graphs that represent those. It says, then write two inequalities to compare the two numbers. Well, it's easy. Look at where they are. One of them is -7, is something -3. And this is just like the bell work. What are we going to put in the one I just drew up there? Am I going to put less than or greater than? Less than. Remember, the big mouth eats the big number. Okay, this is the correct symbol right here. The big mouth eats the big number. -3, even though that number 3 looks smaller than that number 7, it is negative. It's farther to the left. Another way some students look at it, they think of this number line, it gives you the same symbol that I just drew up here. Notice that's the same symbol. It points that way. -3 is something -7. Most people are fine writing that inequality. The other one is the one that gives people fits. What about if you change the order and say -3, -7? You have to reverse the symbol. You have to reverse the symbol. Now, since The negative 7 is not written first. Now it's written second. You have to reverse it. So this right here, what I just said about them being the same, is not true. You have to make sure to reverse the symbol. Or you could just tell yourself the big mouth eats the big number. So on the graph, negative 7 is to the left of negative 3. So negative 7 is less than negative 3. Okay. On the graph, negative 3 is to the right of negative 7. So negative 3 is greater than negative 7. So those are your two inequalities that we just drew. Negative 7 is less than negative 3. And negative 3 is greater than negative 7. Very, very simple. Okay, take about 30 seconds to do this one. Okay, just like the one we just did, now we're not graphing them, we're just writing the two inequalities. If you have to graph it, it's okay. But there's no need to. So if we do it in the order it's written, negative 1/2 something negative 3/2. Okay. Negative 3/2, that number 3/2 on the bell work was bigger than 1/2, but it was dealing with positives. Now it's smaller. So remember, the big mouth eats the big number. That's how the first inequality should look. You could have them in backwards order. It's okay. Just make sure the mouth is eating the negative 1/2. If you had to graph it though, if this was negative 1 and this is negative 2, negative 1/2 would have been right there. And negative 3/2 would have been right there. So if you had to graph them to see where they fell on a number line, that's where they would fall. The other one that you should have written should have looked like this. Negative 3/2 is something negative 1/2. Again, the big mouth eats the big number. Make sure the point is pointing to negative 3/2. Here's example number 2, ordering real numbers. 3 different values. We only had one on the bell work that was something that was a different version of a number. All the rest of them were decimals. This one has 2 fractions and 2 that are represented with decimals and one that's an integer. So 3 different versions. Negative 4/5, 1.8, 3/2, and negative 1. A lot of times it's easier for people to make them into decimals to see everything. So if you need to do that, this one's going to stay 1.8. This one's going to stay negative 1. Let's convert the other two. Negative 4/5 means negative 4 divided by 5. That's negative 0.8. And then 3/2, we just did a second ago, was positive 1.5. So now you have all the same version of numbers. It's easier for people to make comparisons. The smallest number is negative 1. We can see it's all the way over here on the left. Then negative 4/5. Notice those are the only 2 negative numbers. Negative 1 and negative 0.8 as I changed it, but negative 4/5. Then the next smallest number is 1.5, which is 3/2. And then 1.8 is the largest one. So that you can see the order then. Negative 1's first, negative 4/5, 3/2, and 1.8. If you do convert the numbers like this, though, at the end of the problem, when it's time to put them back in order, write them in their original form. Don't leave them in your converted form. Okay, take about 20 seconds to do this one. Graph these 2 numbers. You don't have to draw a nice, pretty, perfect line with tick marks that are in the perfect spots and everything. Just show their relation to 0. Okay, this is what I mean by that. I'm still seeing some of you guys, you're trying to be nice and perfect. And there's nothing wrong with trying to be meticulous to where you don't make mistakes. But a lot of times with stuff like this, it's more important just to sketch it where you understand where it is. What I mean by that is if 0 is right here in the middle, then you know that 2.7, if this is 1 and this is 2 and this is 3, 2.7 will be, you know, a little bit past halfway between 2 and 3. So that right there would be 2.7. And then negative 1 and 3/4. Remember, negative 1 is an entire negative 1, so that would be here and here. Negative 1 and 3/4 would be the point where it's negative 1 and 3/4 or 0.75. So that'd be negative 1 and 3/4. Again, you don't have to be perfect with these. You could have drawn this sketched out like this, said that if zero's here, 2.7's about that far, not 27. 2.7 is about that far away. Well, negative 1 and 3/4 is not quite that far away. Notice that's a shorter distance that I have drawn here than I do have there. That's a sketched version of the exact same thing that I have right on top of it. Okay, finding the opposites of these numbers. It says find the opposite of negative 4. Well, negative 4 is here. It's 1, 2, 3, 4 spots away from 0. So the opposite is the same distance on the other side, 1, 2, 3, 4 away from 0. So the opposite is that. It says the opposite is 4 because negative 4 and 4 are on opposite sides of the origin, and they're both 4 units away from the origin. If you can understand the fact that they're 4 units away, absolute value is a very easy concept for you. Take about 10 seconds to do these two real quick. Okay, so what is the opposite of 0? Ask yourself, it's meant to be confusing, it's on purpose. Ask yourself the question, how far away is 0 from 0? 0. It's no distance away. Therefore, its opposite, if you look at the other side of it, will be the same distance away. Its opposite number is 0 as well. What about the opposite of 1.2? How far away is 1.2 from 0? It's 1.2. So if you go to the other side of 0, how far away does it have to be? 1.2. Except when you're looking at it on the number line, 1.2 is right here. The opposite will be the same distance away, but it'll be negative 1.2. Absolute value. If A is a positive number, then the absolute value of A is equal to A. It says if A is a positive number, then the absolute value of A is equal to A. The example is the absolute value of 10. Anytime you see these lines right here, and you guys know I'm going to call on y'all, and I'm not going to pick on anybody, but when I pull your stick, if you say those lines 10 or something like that, I'm going to make you re-say it. So you just assume say it the right way to start, everybody. The absolute value of 10 is 10. If A is 0, then the absolute value of A is 0. So the example saying 0. If A is a negative number, the absolute value of A is equal to a negative number. So the absolute value of 10, notice this is talking about how, remember, absolute value is the distance. How far away from 0 is negative 10? It's 10 units. This will never be a negative value on the outside. Okay. Example number 4 says using mental math to solve the equation. The absolute value of x is 3, but there's two values of 3. Both 3 and negative 3 are 3 units away. Think of that on the number line if you have to. This number 3 over here is 3 away, 1, 2, 3. And this negative 3 over here is 3 units away, 1, 2, 3. So both of those values, 3 and negative 3, are 3 units away. So there are two solutions to the absolute value of x being equal to 3. The other one, on the other hand, is the absolute value of x is negative 2. There is no solution. There is no solution because there's never going to be a value that the distance is negative 2. Remember the two little boys throwing a tape measure back and forth at each other. If one of them's value is 2, when he throws it to the other one, he measures it back, it's not going to say negative 2. So there'll never be an absolute value of something that comes to be equal to a negative number. The only time something like that will show up is if there's a negative outside of it, and then it acts like a parentheses, and we'll look at an example like that when we get to it. But just think of it this way. There'll never be a value that's going to be equal to a negative number. Do these three real quick. Take about 25 seconds. Remember, you're not talking about opposites here. So if you were just putting opposite values, go back, we're going to make the change. How far away is 1/2 from 0? That's what those absolute value lines mean. It's 1/2 from 0. How far away is negative 1.6 from 0? It's 1.6 from 0. How far away, now look at this as if it's two separate things. This is what I was talking about a little while ago. Look at these absolute values as if they're a parentheses in your order of operations. You always do what's inside this grouping symbols right here first. So now it says the absolute value of 3 is what? How far away is 3 from 0? And you get 3. Then this comes down in front of it to give you negative 3. And that's the only time you'll have something that'll come out to be a negative value like that. Example number 5 is using a counterexample. Example number 5 is using a counterexample. Decide whether the statement is true or false. If it's false, give a counterexample. The expression, the absolute value, is sometimes greater than A. True. When A is less than 0, the absolute value A is greater than A. That's confusing for a lot of people, so we're just going to go to the next one. It would take me 15 minutes to explain that one. But just think of the variables. It's just saying which side of the 0 on a number line it is. Think of it that way. The second one says the expression negative absolute value of A is always less than A. That's false. If A is equal to negative 3, then the absolute value or a negative absolute value of negative 3 is not going to be less than negative 3 because this is going to come down and be positive 3 and this is going to come down and be negative 3. So it's not less than negative 3. It's going to be negative 3 in that case. You take about a minute to do these. Again, don't copy down every single thing. Just think about what the three things are asking you. If it's true, write it's true. If it's false, give a counterexample. Remember that sky is always blue example I gave y'all earlier. No, what about when it's black when it's nighttime? Okay, let's take a look at the first one. It says the expression, the absolute value of A is always positive. Positive. So the absolute value of A is always positive. Can we get a negative value that comes out of this? No. So the first one is true. Remember, anything that's inside, if it was the absolute value of 2 or the absolute value of negative 2, both of those values are going to be positive. So when it says it's always positive, that has to be true. B says the absolute value of a number is always greater than the number itself. the absolute value of 2 versus the absolute value of negative 2, just showing two examples. The absolute value of 2 is going to be 2. The absolute value of negative 2 is 2. In this case right here, the absolute value of it, 2, is greater than negative 2. So it would be true for the one I have circled. But when you look at this other one over here, the absolute value of 2 is 2. It's the same. It's not greater than. So that one would be false right there. And that would be the false. That would be the example. What about positive 2? That's 2. So it's not greater than, it's the same. And then C says the symbol negative A is sometimes equal to opposite A, the absolute value of A. Negative A, so let's use the same numbers. Negative 2 is equal to the absolute value of 2. Okay, let's see what we got right here. This says negative 2 is equal to 2. Is this true or false? The absolute value of 2 is 2. Is this a true statement right here? No, it isn't. So this would be your counterexample right here. Negative 2 is not equaled to the absolute value of 2. And let's do the last checkpoint problem. It says compare negative absolute value of negative 4 and 4 using less than, greater than, or the equal symbol. Well, this one right here, like I said, it's represented negative and then the absolute value of negative 4. This acts like a set of parentheses, so do what's inside of that first. The absolute value of negative 4 is 4. Then this little guy comes down in front of it to give you negative 4. So now you have negative 4 something 4. And we know that negative 4 is smaller or less than because the big number eats 4. So this is what your inequality should look like. Negative, if you go all the way back to the original version, is less than 4.